In this video, we discuss analysis of variance, or ANOVA. What is ANOVA? The one-way ANOVA test is a statistical procedure for testing whether there is significant difference among three or more means. One-way ANOVA is used to test for evidence of a relationship between one categorical variable, the populations, and one numerical variable, the means. It's important to remember that a significant result indicates that there is a high probability that a difference in means is not due to chance, but it does not indicate where this difference lies. The basic procedure for conducting ANOVA, at least using technology, is quite similar to that of any other significance test. State the hypotheses. The null hypothesis is always that all of the means are equal. The alternate hypothesis is always that at least one of the means is different. Then use technology to compute the p-value for the observed statistic. Compare the calculated p-value to the significance level alpha. Make the decision. If p is less than or equal to alpha, reject the null hypothesis in favor of the alternate hypothesis. If p is greater than alpha, fail to reject the null hypothesis. Finally, summarize the results. Let's consider two examples. Does the mean height of mountain peaks differ among Alaska, Colorado, and California? A random sample of heights in feet of mountain peaks in the three states was obtained. Does this data give evidence that the average height differs among the three states? The collected data is given in the table. Notice that each state does not have the same number of observations. This is okay. To proceed with the solution, we state the hypotheses and put the observed data in lists L1, L2, and L3 as shown. Then we select ANOVA from the Statistical Tests menu and indicate our input lists separated by commas. The output screen gives the calculated p-value of 0.00896, which is less than 0.05. Therefore, we reject the null hypothesis and conclude that there is evidence of a difference in mean peak heights among the three states. Let's consider another example with a social dimension. Does having a pet dog along reduce stress levels in pet owners? To answer this question, 45 female dog lovers were recruited to participate in a study. 15 of the women were randomly assigned to each of three groups to do a stressful task alone, the control group, with a good friend present, or with their dog present. The subject's mean heart rate during the task was used as a measure of the effect of stress. The heart rate data arranged by group is given in the chart shown here. There are 15 observations in each group. Looking at the chart isn't all that instructive, so we need to conduct a statistical test. To proceed with the solution, we state the hypotheses and put the observed data in lists L1, L2, and L3 as shown. Then we select ANOVA from the Statistical Tests menu and indicate our input lists separated by commas. The output screen gives the calculated p-value of practically 0. Therefore, we reject the null hypothesis and conclude there is evidence of a difference in stress levels among the three groups. We don't know, however, the answer to our original question. Does having a pet dog along reduce stress levels in pet lovers? We know there is a difference in stress levels among those in the control group, those with a good friend present, and those with their dog present. What is this difference? To determine this, we need more analysis. We could compare the group means in pairs using t-tests. Let's first compare the dog group to the control group. To inform what to choose for the alternate hypothesis on the t-test, we compute one variable statistics on list 1, the dog group, and list 3, the control group. The dog group has a mean heart rate of 73.48, and the control group has a mean heart rate of 82.52. Thus, we choose mean 1 less than mean 2 when conducting the t-test. The output screen shows a p-value of 0.007, which is less than 0.05. Thus, there is evidence that having a dog present reduces stress in participants. But is having a dog present better than having a good friend present? Now we compute one variable statistics on L1, the dog group, and L2, the friend group. The dog group has a mean heart rate of 73.48, and the friend group has a mean heart rate of 91.32. Thus, we choose mean 1 less than mean 2 when conducting the t-test. The output screen shows, again, a p-value of essentially 0. Thus, there is evidence that those with a pet dog present experience less stress than those with a friend present. Ironically, by comparing the friend group to the control group, we can actually conclude that there's evidence in this data that having a friend along may actually increase stress levels.